With the new Turing Complete update, a lot of players are jumping back into the game, and the first few levels can feel either way too simple or weirdly confusing. But these levels are not just filler, they teach the basic building blocks behind real computers: wires, signals, and logic gates. So let's start from the beginning. The first level is called Humble Beginnings. All you have to do here is connect a wire from input to output. But what's actually happening? Those two colors you'll see constantly, green and red. Green means 1, red means 0. At the most fundamental level, these are the only type of information computers use to communicate with each other. And more than that. To understand how ones and zeros become useful information for the computer and eventually for us, it's worth building a deep, solid, fundamental understanding early on, level by level. In the first level, we learned that a signal has to be transported from input to output. That signal can either be red or green, and we use a wire to reliably carry it across. The truth table for this circuit is the simplest one possible, and looks like this. This means that when our input is red, we want to receive the same red at the output as well, and other way around. No additional components needed, just a reliable wire between input and output. That's it. But what if we don't want the same signal at the output? What if we want the opposite? To make that possible, we need something more than just a wire. And that's exactly what level 2 introduces, the NAND gate. Now, an important detail here. A single input only gives us one variable. There's nothing to decide. But with two inputs, we get a combination of states that the circuit can actually react to. That's exactly how the NAND gate is built. Two inputs, one output. Depending on the combination of both inputs, the output changes. Since every component decides its output differently based on its two inputs, firstly, it's important to really internalize the NAND gate and how it behaves. Because our next goal, inverting the input to get the opposite output, requires exactly this component. Looking at the truth table, the NAND gate outputs green in every case except for one, when both inputs are green at the same time. That's the only combination that flips the output to red. Every other combination keeps it green. So the NAND gate is not just an inverter. It only outputs 1 when both inputs are 0. And, of course, the other way around. With that knowledge, we can connect one single input to both inputs of the NAND gate at once, and the condition for an opposite output is always met, because both inputs are always identical. This means the output is always the exact opposite of the input. One input in, the opposite out. And with that, we haven't just understood level 2, we have applied the fresh learned NAND gate to build something new, a NOT gate, a component that does exactly one thing. Whatever signal goes in, the opposite comes out. And that's level 3 done and understood. And just like that, we built a NOT gate from scratch, starting from nothing but a question, a bit of research, and some experimenting. The same principle applies to everything that follows. With enough patience and persistence, those same building blocks eventually add up to something as complex as an entire computer. In the next episodes, I will walk through the increasing complex levels, as detailed as necessary but as short and simple as possible. So if you have any questions, ideas, or requests, the comments are more than welcome. See you in the next one.